So if they're both cubes, we're going to look at a format. Okay. So one thing we could do is say, well, one of the zeros here, I can tell by looking at it. If I plug in 1, right, I know that 1 cubed minus 1 is 0. So let's do that. Let's plug in 1. And plug it into here. Now remember, we're missing the x squared and the x here, so we're going to plug in 1, 0, 0, negative 1. And when we complete this, x squared plus x plus 1. And then we can solve that like normal. So you can see that I don't have to give you and tell you, oh, one of the factors is x minus 1. It's so short that I can tell by looking at it, oh, if I plug in negative 3 into here, negative 3 will give us negative 27 once we cube it. And then negative 27 plus 27 is 0. So I can figure that out just since the polynomial is a little bit smaller. Okay. Now, if we went through and did this enough times, which I don't know if I want to do all of them, but if we did it enough times, you would see a pattern emerge. So what I'm going to show you now is that this is a fine way of solving this. Is if you have a small polynomial and you can tell by looking at it, oh yeah, negative 3 when I plug it in gives me 0, then you can just go ahead and use synthetic division. And you can get your answer. Oops, not 0, negative 3. Right? We got x squared on this one. We get x squared minus 3x minus 9. What's that? Positive 9. Thank you. Positive 9. If we did this enough times and I said, well, why don't you look for a pattern? Maybe we can skip this. You'd find out that there indeed is a pattern. And I'll show you what that is. So for something like this, x cubed minus 1 cubed, they both have to be cubed. We'll know that it does factor this way. We know x minus 1 is already a root because we're trying it right here. Same thing over here. If I have x cubed plus 3 cubed, that's the first part. If I take this, I'll have x squared plus x, and I'll leave the 1 in there, plus 1. And here you can see I get x squared minus 3x plus 9. There's something to it. If you start looking at some patterns here, you can see, well, we've got a minus 1 here, a minus 1 here, plus 1 here, and a plus 1 here. We got a plus 3 here, plus 3 here, minus 3 here, there's a plus 9 here. Yeah, let's just do all of them. Okay, so here we can see if I plug in 5, that will be a root. So 1, 0, 0, negative 1, 25. And what I'm looking for is just a pattern. Is there something that's going on here that maybe I don't have to quite do as much? So I know that five was a root, so x minus 5 is a factor. And left over is x squared plus 5x plus 125. Oh no, plus 25, sorry. Once again, we can see, well, we got this. That's the wrong number, isn't it? That should be a 5. 5 cubed. So I got 5, negative 5, negative 5, negative 5, positive 5, and then 25. So can we see a pattern between all of these? Okay. That's the idea. So maybe on this one, this last one here, can we use the pattern and say, well, what will the factors be without actually doing the synthetic division based upon this pattern? What do you think? So let's look at the first one. How can we go from here to here, here to here, and here to here? Do you see any pattern there? Alright, so what should I put? What should it be here? X minus 2. Huh. It seems like it's the same thing. Just without the cubes, right? All these is the same thing without the cubes. Did the subtraction or addition matter? That change anything? Not really. You know, yeah, if it's plus here, it's plus here. If it's minus here, it's minus here. But it seemed to work for both. What about the remaining terms? Okay, so over here, this was negative 1, negative 1. Over here was positive 1. This was negative 3, positive 3, positive 3. This one's negative 3. This was negative 5, negative 5. This was positive 5. So what do you suppose we should have here? X squared plus 2x, right? So it seems to always be the opposite of the first two. This was negative, negative, went to positive 1. Positive, positive, went to negative 1. Negative 5, negative 5. This is positive 5, so negative 2, positive 2. And what about the last one? Yeah, plus 1, so we had negative 1, positive 1, positive 1. Positive 3, negative 3, positive 9, which is 3 squared, right? Negative 5, positive 25. So negative 2, positive 2, plus 4. Yeah, so there seems to be there's a pattern with these, what they call difference and sum of cubes. If you just have two cubes, one's usually a variable and the second one's a number, and they're either being added or subtracted, you have this pattern here. Now it's up to you, because you saw the first part. We went and did the synthetic division, and it's just like the problems right above it. That's why they're together on the same worksheet. But there's also this pattern that if you would prefer to use, you can. It's kind of like when we had x squared minus 4. You could go through and do all the normal work, or you can say this was a difference of squares, and you know it factored to x plus 2, x minus 2. There's a pattern when it was a difference of squares. So it's in that family of shortcuts where no matter what, we always have a pattern with sum and a difference of cubes. Use it if you like. I highly suggest it. It'll save you a lot of time. So it's one of those things on, how's that person finishing the quiz or test so much faster when they're getting it right? They're maybe not cranking out and doing synthetic division. They're using this instead. I'll show you an observed pattern, just what we just stated here, that these two were always the same. Right? These were always opposites. And that was the same. These were opposites. I'm talking about the signs. This is a -1, +1. So those signs were the same. These were the opposite. Those were the same, opposite, and so on. So that was the pattern we all looked at and observed. And then the last number was what? Yeah. It was always, with a sign only, was always positive. No matter what, since this is a squared number, whether it's +3 squared or -5 squared, this always came out to positive on every single one because it's squared. No matter what, if you square a number, it's positive. So if this helps, we have same, opposite, always positive, which is SOAP. Not very exciting, but it does work sometimes. If you're just getting confused on the signs, on what's next. Is this one negative or is this one negative? How do you know when the signs change? So that little acronym might help you in the beginning. All right. So far, so good. So I'll have you guys finish those. So for each of these, we know that like on... Actually, I won't have you finish these. Just we can leave them as. Alright, so far so good. So that should wrap this up here. That ends up this. Alright, the next thing we're going to do is do this process right here in reverse. Let's do all this backwards. That's usually how math works, right? You learn how to add, then the next thing you do is learn how to subtract. That's just undoing or doing the backwards of addition, right? So your question is now the answer, and the answer is now the question. So what if I give you the roots? Can you come up with the equation? So we're just reversing the roles. So what if I gave you -3 as a root and 2 ± 3i as a root? Can you come up with this full polynomial? Just this part. The x³ minus x² plus x plus 39. Okay? And of course you can. Okay? Of course you can. So let's start off with, let's say, here. Let's start off with this problem. Did this one yesterday, and here's all the work, and we're pretty sure that this is the answer, right? How could I go backwards? How do I do this whole process backwards if I know these are the roots? Well, first of all, just understand you're getting a bunch of these. Sub, actually. And maybe a little higher. There we go. You're getting a bunch of factors. I need, since I know this is a third degree, I need 3 of these. So I know x minus 3 is one of them. Okay, here's the beginning of my answer. Right, and I can get that from my list down here. I know x minus 3 is one of the factors. What do I get if my answer is 2? What would the factor be? X minus 2. And what about here? X plus 2. Hey, there's your polynomial. All you have to do is multiply all those together and we'll get our answer. So it's more of a, coming up with these isn't so bad, but you have to multiply them all out. So let's do that. So multiply the first 2 together. Multiply those 2 together and we get x² minus 5x plus 6. -3 and -2 is -5. -3 times -2 is positive 6. Okay. And then multiply that by x plus 2. Do some distributive property. We've got 6 distributions to do. So I'm going to multiply x times that, x times that, x times that. So we'll get x to the third minus 5x squared plus 6x, and then distribute the 2. Altogether, 6 of them. So plus 2x squared minus 10x, right? And plus 12. And you can see it taking form, right? We have x squared, we got a plus 12. So we have x to the third. But then we have some like terms. We don't have negative 3x squared yet, but we do have a negative 5x squared and a positive 2x squared. So there's your negative 3x squared. And we don't have a negative 4x, but we do have 6x minus 10x. So we have negative 4x that way. And there we go. We just went backwards and reversed the process. So if you're given the polynomial, you can find the roots. If you're given the roots, you can also work backwards to find the polynomial. Not too bad, right? And we practiced this a lot last week on Wednesday. Alright, so let's pick another. I'm going to have you guys try it out. Let's go back to the homework. Here. Yeah, let's have you guys do number 4. Right. One more time. Do number 4, new page. Okay, there you go. Go ahead and do number 4. What did the answer come out in number 4?
5 and negative 2.
Alright, so we have 3, 5, and negative 2. Okay. Now go ahead and work backwards and come up with our polynomial. Give that a shot. Everything worked out okay?
Yeah.
All right, so we get the picture. Okay, good. Let's
Right here?
look at, well, what happens if the roots are irrational with square roots and stuff. So it's one thing to put x minus 5, x minus 2, x plus 3, no problem. Well, what if it's x minus 5, x minus this whole thing? And so let's look at that. Let's try to do number 5 in a similar fashion. So how do we write this out? Okay, so I know x minus 5, right, is one of the roots. Okay. So how do I write this? It's similar. You just do x minus, okay, and that whole thing. But we have to do one at a time. So it's 1 minus negative 1 minus or plus root 22. Okay. And then we'll have another one here. Still x minus negative 1 plus root 22. And there's 2 parentheses here, yeah, for each one. Okay, so we're always going to use minus here. Okay. Only thing that changed actually should have been was this. Dang it, I'm not doing well here. Had a good start. Let me correct this for a second. Minus root 22. There we go. So then it becomes, well, how do you multiply all this together? Is there anything different or the same about it? Multiply these together first. Don't try multiplying x minus 5 times this. Because of the nature of this problem, a lot of things will end up working out neatly. So we want to always multiply the radicals together. And the next example I'll do will have the imaginaries. It'll be the same thing. So multiply them together. Leave this x minus 5 for the very end. So here we go. I'm just going to distribute, kind of like distribute this negative. So it's going to be here, here. That's the first thing. So plus 1 minus root 22. Distribute the negative there. So we're going to have x plus 1 plus root 22. All right, so at this point we can simply just start doing the distributive property a whole bunch, okay? But you might want to look at this first. This has the same format as something like this. In structure. Don't pay attention to numbers, but in structure. Meaning we have something that's the same in the front of both of these. They're both x plus 1s. And we have the same thing at the end of both of them. They're both root 22s. And one is plus and one is minus. Right? And by doing that difference of squares bit that we talked about earlier, that I'll know the answer is this. Okay? It's x squared minus 4. Okay? And if I went through, I could do this distributive property, x squared minus 2x plus 2x, which cancel out. And then negative 2 times 2 is negative 4. And that's a fast way to get to our answer. Okay, so I'm going to use this idea right here. Instead of doing the whole thing, multiplying and foiling and do all that, I'm going to understand that, well, it's really just going to be the first thing squared, which is x plus 1 squared, minus the last thing squared, root 22 squared. So we're going to have x plus 1 squared minus root 22. Okay. Squared. And this will take some getting used to. Undo it. There we go. Okay, well, that's why we're going to practice several times. And we still have this x minus 5 just hanging out. That's going to be the very end. So let's simplify all this. What do we get? Okay. What is x plus 1 squared? X squared plus 2x plus 1 okay. And then we have minus 22. Okay. Because the square root of 22 squared is just 22. The square and the square root cancel out. Okay. X squared plus 2x minus 21. Shoot, we finally multiplied those two together. You might notice where else does that show up? Right here. Well, that's the same thing we got from the synthetic division, right? So we are indeed doing it correctly. We just did the whole process backwards. We just did that whole process backwards. I wonder if we could complete the square backwards. That actually might be easier. We'll give that a shot next time. Alright, and then lastly, I'll leave this, we don't need to go through this part, but the last thing would be, of course, to multiply both of these together, and then the answer would come out to this, the original question. So, just, yeah. let's look at this. I wonder if this process we did, that's the way I've always seen it done, but I just thought about with this right next to here, is it possible just to do the completing the square backwards? Yeah, so let's take our answer, x equals -1 plus or minus root 22. And let's just do this backwards. So in order to get to this point, the last thing we did was this, subtracting 1 on both sides. So maybe we should add 1 on both sides. We'll get x plus 1 equals plus or minus root 22. And then what we did before that is square root, so maybe I can square both sides. So I get x squared plus 2x plus 1, which equals 22. And then over here I added 22 to both sides. Okay, so I'll subtract 22 to both sides. Alright, and you get the same answer. And that equals 0, but that part's not important. So yeah, looks like we can complete the square backwards as well, or we can use this method. I guess you can take your pick. I kind of like this though. That's not in the book, but that seems, you know, especially when they're side by side, you can see them. How it's the same thing. Alright, so let's do one more but with imaginaries. One more but with imaginary roots. It's going to be a similar process. So that's it. Let's go over here. See, but I did we did this one with quadratic formula, which I'm pretty sure we cannot do backwards. But we'll try it anyway. We'll try doing completing the square. Alright. So our goal is to try to do this part backwards. I already know it's going to be f of x equals x plus 3. With this part right here, that polynomial, that gives us the answers of 2 plus or minus 3 root I. I don't know. So what did I do before? In this one I added the part here, squared both sides, okay, and I subtracted it over. I think I can do that again. So if we have x equals 2 plus or minus 3i, let's start by subtracting 2 on both sides. We have x minus 2 equals plus or minus 3i. And remember, what does this mean? What is I? It's the square root of -3. Because the I is like the square root of -1. We have a 3 there already. Then we can square both sides. We have x squared minus 4x plus 4 equals -3, and then add 3 to both sides. So we get x squared minus 4x plus 7. There we go. And once you multiply all of those together, you'll end up with our original thing here. Oh, wait a minute. Yeah, that's right. Take some getting used to. Alright, so let's see how much time we got. Okay, last thing we're going to do. That's going to be the first part of your homework. It looks something like this. It comes up. Yeah. So that's what these problems are all about. I give you here's the directions that go along with them. It's got some fancy language in here, least degree with integral coefficients and stuff. It's basically just working backwards. Okay. So that's what those are. After that, you're going to do these. Now these are, look at all these problems, 23 through 32. Isn't this what we just did last night? Is this what we did last night? Yeah, except for one thing, and what is that? What is that one thing that's different? Look at the homework question and look at these. What's that? Okay, so some of these have 4 answers because they're x to the 4th. So these last 3 questions have 4 coefficients. And what? Okay. And what's the other thing that's the big thing here is that I don't give you the first root. I'm not telling you where to start. On all the other problems on the worksheet, as you see, it'll say comma x plus 3, so you know your first synthetic division where to start. So what if I don't tell you what one of the answers is? How do we get all of them anyway? Okay. So that's the second part of your homework. That's the second part. So let's investigate a little into that. Okay, so let's go back to number 3. Take a look at another one. So we have a pattern that actually emerges. After doing enough of these, some guy saw, after doing a whole bunch of these, saw that, well, you know what? All my answers always that come out to be rational anyway, not the square roots and the i's, but the ones that come out to be rational, they all have to do with these numbers, right? And somebody figured out that if I took all the factors of this last number, so like 1, 2, all the factors of 12, 3, 4, and what's another one? 6, and all the factors of the first coefficient, in this case it's just 1, right? And I did this like a multiplication table, that all the possible answers are on this list. They all have to be plus or minus one of these numbers. Right? And if we look at our answers that we did get, yeah, we got positive 2, negative 2, that's on the list, and positive 3, that's on the list. So this was called the rational root theorem. That all our rational answers, the answers with no square roots and no i's, they all end up on this list. So if we don't know where to start, or we don't have a, like on the last problems from last night, if we don't give you a starting point, you at least narrow it down. You're not going to start off with like, oh, let's see if negative 5 is an answer. You don't have to check negative 5. It's no way possible for it to be an answer. But, I mean, there are 2, 4, 6, 8, 10 answers here, so it narrows it down a little bit, excludes some numbers, but you still have a lot of guessing checks. So what you'd have to do is maybe go through this and say, I want to know if 4 is an answer, right? And you take your coefficients, and you'd go through the process, and your goal is to see, is this a 0? If it's a 0, then you know, okay, that's one of the answers. But if this comes out to anything else, then you say, okay, well, that's not it. Go try another. So that's the only difference between last night and this one, is that I'm not going to give you the first one. You'll have to use this idea right here that pick some numbers at random, and once you get something that is a 0, you know you've completed that first part. Okay. And then after that, you can go ahead and do the quadratic or the factoring or completing the square to finish the problem up. Okay. So something like a number, let's say, addition. Let's look at, let's say, number 30. Let's look at number 30 together. Okay. I don't know where to start. Okay. But what are all my possibilities here? Okay. Factors of 40, what are they? Okay. So no matter what, we always have 1. What else goes into 40 evenly? 2, 3? No. 4? Yeah. 5? 6? 7? 8? Yeah. 9? No. 10? Yeah, 10 goes in there. And we can get higher and higher, like 20 goes into it, right? And this is still just a 1 here, so 1 times all of these are just going to be the same. So these are all my possible roots. Very good advice. Start with the smaller numbers first. Okay? If this number is relatively small, the roots are going to be relatively small. If this number is like 600 something, I'd say one of these is going to be more likely. So the size of your last number here is an indicator of what your roots are. So what number do you want to try first? 2? Let's see if 2 is a root or not. So let's plug it in. 1, -9, +24, -6, -40. So 2 times 1 is 2. -7. We get -14. That comes out to 10. And 20. That comes out to what? 14. 14 times 2 is 28. And it's not 0, so that means 2 is not a root. Let's try another. What do you want to try? Gotta make a decision. 4? Alright. Yep. So we try this. So this is where synthetic division comes very handy. Imagine if we had to do all this by long division. It would be taking forever. Okay, so we'll get really good at this. But, you know, at first we're just going to start a shot in the dark. Okay, it's 4. Does 4 work? Yeah? I got 0. Okay, yeah, so 4 is the solution. It came out to 0. Alright, so for my solutions, I know I have 4 answers total on this list. Okay, I need another though. Okay, I need another. So this one I'll just give to you for time's sake. After more trial and error, we'll come out with -1. And we'll do this again, -1. So we have 6. And what's next? Is that good, right? -6, +6, yeah, 10, and then -10. Yeah, there's another root. So I know that -1 is also a root. And once we get down to 3 numbers, that's when you have a quadratic. Now this is x squared minus 6x plus 10, and that's when I can go over here and say, well, what two numbers multiply to 10, add to negative 6? Are there any? No, so you go through and do the quadratic formula or complete the square to get the remaining two. But you always have to do this as many times to get down to a quadratic. You have three numbers left over. Once you have three numbers in your synthetic division, that's when you know you can go to here. You don't have to keep doing guess and check. Alright, so once we finish this, we'll have, let's see, x squared minus 6x plus 9, okay, plus 10 minus 9 equals 0. X minus 3 squared plus 1. And I can see here that we have an imaginary answer because I got a negative over here. Square root both sides, I'll get plus or minus I. Right, square root of negative 1 is I. And then add 3 to both sides. So my last two roots are going to be 3 plus I and 3 minus I. There we go. So a lot of trial and error. Alright, so I'm going to leave you with that. And just